Organized space research activities in India started in 1962 with the creation of the Indian National Committee for Space Research under the leadership of Professor Vikram A. Sarabhai.
It is not accidental that on the soil of India, the great space powers, the United States, the USSR and France, are collaborating with us at the equatorial range near Tumba.
The rocket launching facility at Tumba is unique. It is the only rocket launching facility along the magnetic equator in the world.
And even the United Nations sponsorship of this range is not merely a matter of form, but constitutes an umbrella under which, regardless of political differences, nations can collaborate in the peaceful uses of outer space.
My interest has been on many aspects of Earth physics, and in particular on problems of the Earth's atmosphere. Firstly, the lower atmosphere in which the weather phenomena take place. Secondly, on the upper tenuous atmosphere which guides radio waves. And thirdly, on radiations from the sun which give all energy to Earth.
We had four major problems, one on atmospheric density, two on satellite radio beacons, then rheometer rocket payload, and fourthly on space volume.
We are currently busy with the gathering of information about upper winds and temperatures over Tumba up to about 60 kilometers. This information will be useful for supersonic aviation also.
It will be our constant endeavor in the years to come to provide the peaceful uses of outer space for the real problems of this nation.
What a grand and wonderful thing is the Earth's atmosphere. Pervasive, protective, living and life-giving. The atmosphere is global. Over any place, however, weather has its moods. Can we predict them? The scientist believes in the laws of physics and is confident that he can. Weather services have till recently depended on observations made at land and ship stations and on upper winds and temperatures determined from balloon observations. They receive the data by radio telemetry and by broadcasts, both national and regional. The data are collected at national meteorological centers like Delhi or Pune in our country, and forecasts are issued for aviation, shipping, farmers and others. We have now begun to get extended global cloud pictures taken from orbiting satellites. They cover the whole oceanic area, the whole of the northern and the southern hemisphere, desert areas, the glaciers, and this is a new additional information which is now forthcoming due to the satellites.
The main activities confined to conducting scientific research with the help of balloons and rockets and receiving real-time telemetry signals from the scientific satellites for the study of cosmic rays, weather, ionosphere, and X-ray astronomy.
Mr. Murthy, could you tell me why Tumba is so important?
It is the only station located along the magnetic equator from where the scientific phenomena along the magnetic equator, like the electrojet, could be studied in detail. So far we have had collaboration with 5 different countries. They are the United States of America, the USSR, France, Japan, and West Germany. And scientists have come here for experiments in terms of collaboration. Quite a number of rockets we have launched with various types of payloads, and most of them are all successful. We have many educated scientists and engineers who can be usefully employed. They can contribute a lot to establish the indigenous technology and know-how. This will be useful in the field of electronics, instrumentation, control and guidance systems, and more than all, the vehicle technology, which will be of great value to our country. And it will give the required industrial spin-off, because many industries could contribute quite a lot for the development of this technology.
Roger. X-ray, LP and X-ray. Roger. Telemetry. Roger. All stations stand by. Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 7, 8, 9, 10. The 15 seconds. 20.
Launching ground calling control. We are ready to launch. All set. Over.
Control calling launching ground. All set.
Launch! Go!
Balloons carry instruments to the high altitude for the study of cosmic rays and X-ray astronomy. The information obtained is very important and will help in solving the riddle of origin of the universe, the knowledge of the ultimate, for which the man has been curious over ages. The national facility at Hyderabad for conducting balloon experiments has been established by the group of scientists interested in cosmic ray research at the Tata Institute of Fundamental Research, Bombay, and is available to the scientific community at research institutions and universities in the country and abroad.
Specially instrumented aircraft and satellites are being sent up for the measurement of the Earth's resources. These data are sent back to the Earth in the form of photographs. This technique is known as remote sensing. This is nowadays being applied for detecting the plant diseases in good time. These pictures of coconut trees taken for the first time are to be related to the information of the individual coconut trees at the two research stations, Kasaragod and Kayamkulam. This is something like studying the case histories of patients and deducing their illnesses from symptoms.
Dr. Sarup, what fields in radio astronomy are you particularly interested in here?
We have set up the radio telescope for studying radio waves that come from distant stars and galaxies in our universe, using moon as a tool. As the moon moves in the sky, a distant radio source is eclipsed by a sharp edge, and thus its position is determined very accurately. This is a very powerful method, but has not been exploited so far because of a lack of suitable instrument. The radio telescope that we have set up is one of the largest of its kind in the world.
Dr. Silver, what do you mean by optical tracking of satellites?
In optical tracking, one tries to photograph the satellite against the background stars which serve as a reference frame, and to time this event accurately so that computation of the overall orbit of the satellite may be possible. Such studies have, during the past 10 years or so, given much information about atmospheric air densities at a height up to almost 1,000 kilometers or so. They have also helped in a better determination of the shape of the Earth and of intercontinental distances. The position of the Nainital Observatory, for instance, is now known to an accuracy of 10 meters.
Position you mean on the Earth?
Yes, sure, on the Earth.
Well, this is one of the top solar observatories in the world. We have got an active group who are working on the solar prominences, on the solar chromospheric flares, on the photospheric weak magnetic fields, and so on. We are inside this horizontal solar telescope, and by studying the solar lines, we can tell many things about the conditions occurring in the solar atmosphere.
Space research has given a new dimension to modern communication, in particular to television. It is estimated that with an annual investment of about 30 crores, one can provide television to all the 560,000 villages in India over a 5-year period.
Now let's look at this aspect of communications. The synchronous satellite will be over the equator, somewhere around here perhaps. And the fact that from an altitude of about 40,000 kilometers, it can be seen by a very large area, but we are going to focus the beam to a region such as this, will permit us to have a high signal strength over all this bit. And the biggest breakthrough that is likely to take place is the great economy in the cost of the ground station that you can take place. A normal Earth ground station, such as RV, cost several crores of rupees. But with increase of power on the satellite, it would be possible to directly receive television sets, in television sets with small antennas, signals, and this whole installation might cost no more than 2,000 rupees or so. Now, notice the tremendous difference between several crores and 2,000, and this is the advanced technology which has been possible with this thing. Not only television, for point-to-point communications between our major metropolitan areas, it should be possible through a national satellite to have 3,600 high-quality telephone channels, as we are now planning in 1975. And this should make possible direct dialing on your telephones from any part of India at a minimum of cost. The experimental satellite communication earth station at Ahmedabad, which we have set up through the generous assistance of the United Nations Development Fund and the International Telecommunication Union, is a unique example of an institution to provide advanced training and research facilities in the field of satellite communications. In my opinion, the aspect of space research which I would like to stress most is in relation to the national capability, the self-confidence that this will generate. And if I were to give my own evaluation of this, I think the benefits of these far outweigh all the rest that we have been talking about.